Hey guys, today we're going to talk about section 3.6, which is finding the real zeros of a polynomial function. Last class we talked a little bit about polynomial functions and the fact that the x-intercepts are the factors of the polynomial, or they come from the factors of the polynomial. But everything that was given to us last class was already in factored form. So today we're going to figure out how do you factor a polynomial. We know how to factor a quadratic, but there's not a factor by grouping way or a method like that when it comes to polynomials. So that's the main thing we're going to talk about today. So first, the number of real zeros. We need to know how many zeros or how many x-intercepts we're looking for. And in general, if you have a polynomial of degree n, there will be n real zeros. Now, the definition says you will have at most n real zeros, and let me explain that in a second. But if I'm looking at a polynomial of degree 3, odds are, and for us, we are going to have 3 zeros. Okay, there are going to be 3 factors, 3 x-intercepts that we need to find. If there is a degree of 5, then there will be 5 zeros. Now, there doesn't have to be 5 zeros. There could also be some complex solutions, but we're not going to do that. We're not going to have imaginary numbers and things like that. But they do exist. So actually what you have 5, or you could have 3, or you could have 1. They kind of count down by 2. But for us, the ones that we're going to do, whatever that exponent is, that's how many real zeros you're going to have. Okay? Now, before we get into this, I want you to think about numbers for a second. So, here's my question. Is the number 7 a factor of 1057? Is 7 a factor of that? Well, how could you tell? How would you know? Well, you could divide. You could just literally take 1057 and divide it by 7. So 1057. Now I'm going to do it the long way, and there's a reason for this. Okay? So don't just plug this in your calculator. Do it the way I'm doing it. So 7 does not go into 1, but 7 does go into 10 one time. 1 times 7 is 7. Subtract, figure out how close we got. 10 minus 7 is 3. Bring down the 5. 7 goes into 35 5 times. It goes in 5 times evenly. Bring down the 7. 7 goes into 7 once, so that's our answer. So the fact that, let me go ahead and do that. The fact that 7 divides into 1057 and there's no remainder, that it goes in evenly, that's the definition of being a factor, okay? And that's the same idea we're going to use for this next section, okay? So I'm going to give you a polynomial, so this is a polynomial, and all I want to know is this a factor of that, okay? Is it a factor? Well, we're just going to divide, and we're going to see if it works, okay? We're going to see if this goes into that. And I'm actually going to do it the same way I did this. I'm going to use what is called long division. So I'm going to take this, the polynomial that we're trying to see if this goes into, and I'm going to put it inside a box like that. So negative 2x cubed minus x squared plus 4x plus 3. And I'm trying to see if x plus 1 goes into it. Now, when you do long division, which I am going to show you a shortcut here in a second, but something we're going to do next chapter, you do have to know how to do this long division. Okay, to do long division, what you do is you look at your first term here and your first term here. That's all you look at. And you think, what could I multiply this by to get this exactly? Well, this has a negative 2, this is an x cubed, and this is just a plain x. So if I were to multiply x by negative 2x squared, then that would give me my negative 2x cubed that I want. I need this to be exactly what I have right here. Now, what I'm going to do is I'm actually going to do that. I'm going to multiply. I'm going to take negative 2x squared times x. But I'm also going to take the negative 2x squared times the 1. Okay, if you're going to multiply something, you got to multiply everything. So we're going to distribute, and that's going to give me negative 2x squared. Now, what's the next thing we do in division? We subtract to see like how close we got. Well, if you subtract, remember we're subtracting, so we're going to distribute this subtraction. If you subtract negative 2x squared minus negative 2x squared cubed, which minus a negative means plus, these are going to cancel and they're going to be gone. So let's see what happens over here. This is going to be negative x squared minus negative 2x squared. Well, minus a negative really means plus, so a negative x squared plus a 2x squared is going to give us a positive x squared. Then what do? We bring down the next number, plus 4x. And then we say, okay, again, I'm going to look at the x and the x squared. How many times, what do I need to multiply x by to get x squared? Well, x. X times x is x squared. X times 1 is 1x. And then I'm going to subtract to see how close I got. X squared minus x squared is exact, but 4x minus 1x is going to be 3x. What do? We bring down the next number, plus 3. And again, what would you multiply x by to get 3x? Well, a 3. 3 times x is 3x. 3 times 1 is 3, which means when I subtract these, they're going to cancel, and I'm going to get a remainder of 0. So yes, x plus 1 is a factor of that polynomial. Okay, so how about x minus 1? Go over to the side and see if you can divide x minus 1 into negative 2x cubed minus x squared plus 4x plus 3. Okay, see if you can do that on your own. Pause the video. Pause the video right now so you don't see my work. All right, so after I did the division, I ended up with a remainder of 4. Now, if you did not end up with that remainder, then you may want to go back and look at my work and see where did you go wrong. Usually, look under the line that I drew. That first number, if that does not match yours, so either a negative 3x squared the first time I did the subtraction, or an x the second time I did the subtraction, what may have happened is you didn't distribute your subtractions. So we're subtracting both of these things from the previous row. So that's usually where things go wrong. Okay? So in this case, x plus 1 was a factor of that. So we know that negative 1 is one of our zeros, which means negative 1 is one of our x-intercepts. Okay, this problem would have 3 x-intercepts, and we would need to find all 3 of them. Okay, and we're going to talk about that a little bit later. But again, if you plug a negative 1 into that function, you will get 0 as an answer. That's the definition of being a 0. Okay, so negative 1 is one of our zeros, which means it's one of our x-intercepts. Now, on the bottom here, I am going to show you a bit of a shortcut on how to do this, and it's called synthetic division, and this is what I primarily use. You do need to know how to do long division for something we're going to do later, but let me show you how synthetic division works. First off, if I want to see if x plus 3 is a factor of x cubed minus 7x plus 6, here's what I need. I need to test the 0. So if x plus 3 is the factor, the 0 would actually be negative 3. Okay, I'm going to test and see if negative 3 works. Now, one thing I could do is I could just plug a negative 3 into that. If I plugged a negative 3 in for the x here and the x here, and then I plugged all that in my calculator, if I get an answer of 0, then I'm good to go. That's one of my factors. And if I don't get an answer of 0, then I'm not. That's actually what you're seeing down here. It's called the factor theorem. Okay, and it's actually this second line is the important one that says if I plug a number into the function and get 0, then that means that x minus that number is one of my factors, which is what I need to know. But there's an important reason why I'm going to show you synthetic division and why that's going to be preferable when it comes to trying to factor these polynomials. Okay, so -3. Does -3 go into that? Well, here's what I need. I need to test the -3, and then I need the coefficients of these numbers out here, but I also can't skip any terms. So the fact that we are missing an x squared, I need to account for that. So x cubed has a 1 in front of it. X squared has a 0 because it's not there. The x has a -7, and then there's a +6 on the end. Okay, a +6. I didn't really need to write the plus, but oh well. All right. And here's what you do. You are going to add and then multiply. Over and over. That's all you're going to do. I'm not sure how I came up with that. Multiply. All right. I feel better. All right. You're going to add and multiply. So what do you add? You add columns. So there's nothing here. This is a 0, so there's nothing to add to the 1, but we're still going to add. We're going to add and get a 1. Then we multiply. We take the number on the outside and we multiply it times the 1. So -3 times 1 is -3. And then you add. We're not subtracting like we do with long division. We add, and that's a -3. And then we multiply. -3 times -3 is +9. And then we add. -7 and 9 would give us a +2. And then we multiply. -3 and 2 is -6. And 6 and -6 is 0. Okay, so that is our remainder. If that is a 0, then yes, this is a factor of this. If it is any other number in the world, then no, that is not a factor of this. Okay, now, why is that method better than simply plugging a -3 into this and seeing if we get 0 as an answer? That would mean it's one of our zeros. And in this case, it would have worked. Because here's what just happened. The x cubed, when you divide, it turns into an x squared. So this is actually a quadratic. This is x squared minus 3x plus 2. That is a quadratic, which means I could factor it the way I factor quadratics. I could break it into 2 sets of parentheses, and now I would know all 3 of my factors, x plus 3, and then the 2 I get from here, which means I know all my x-intercepts, and I could graph this polynomial. Okay? Now, I'm not going to do that right now. Right now, I want you to test these two. So see if -2 would be one of our zeros. So again, I'm going to go back to the original. 1, 0, -7, and 6. And I'm going to test that. And then over here, I'm going to test a +1 as well. Again, it's the opposite. It's the number that would be a 0. So you try that, pause the video, and then check yourself. All right, so for the x plus 2, it did not work. You should have got a remainder of 12. Don't look at the 2 6's and then out of habit subtract them and get a 0. Okay, remember we add the column, so that should be a 12. So that does not work, whereas the x plus 1 did. When I plugged in a +1, I ended up with a remainder of 0 over here. Now, going back to my original problem, once I took that x cubed, divided it by an x, it turned into an x squared. Now, we know how to factor this. Okay, factors of x squared are going to be x and x. Factors of 2 that add up to -3 would be -2 and -1. So, yes, the x minus 1 should have been a factor. X minus 2 would have been a factor, but not x plus 2. Okay, and this is what we're going to do. Once we find one factor that works, our x cubed is now an x squared, and we can just factor it. We can do factor by grouping, we can do guess and check, whatever we need to do to factor that. So this polynomial has zeros of -3, +2, and +1, which means that's your x-intercepts. Okay, so I use synthetic division because it breaks this down into a smaller polynomial that we can factor. Okay, so Now, the next question is going to be, from that last example, it appears that I gave you a polynomial and I gave you 3 factors and I just said, here, try them. Okay? So how do we know what to try? How do we know what factors have a chance of working, if there's any factors that have no chance whatsoever of working, and so we don't want to waste our time with them. Okay? There's an infinite number of numbers, and we would like to kind of shrink that pool down a little bit. Well, that's the next thing we're going to learn. Now, this is something you should have learned in Algebra 2, so it should seem a little familiar. And it says, it's called the rational zeros theorem. And it says, if there is a number that is a zero, okay, so this is a polynomial. If there is a number that I could plug in to get 0 as an answer, it has to look a certain way, okay? That number has to be a rational number, so it can be written as a fraction. Now, that denominator could be a 1, so it could just be the number 2. It doesn't have to be a fraction, okay? But it has to be a rational number where the numerator is a factor of this constant on the end, and the denominator has to be a factor of the coefficient of the beginning, okay? So we're going to look at the factors of this number. We're going to divide them by the factors of this number. We're going to look at all the different ways that we can put that together, and those are the absolute only numbers that have a chance of working, okay? So here's what this looks like in a problem. So here's my polynomial. List the potential. What are the numbers that have a chance of working? That's all this says. What are the potential zeros? Well, I need my p's over my q's. Okay, the p's are the factors of this number on the end. So every number that can go into 4. Well, 1, 2, and 4. That's it. Now, 1, 2, and 4. Now, technically, it's the positive and negative versions of those. Because if a number can be divided by positive 2, then it can also be divided by negative 2, okay? Then we do the same thing with the denominator. So again, we're going to look at the first number, and again, all the factors of 4, which are still positive and negative, 1, 2, and 4. Now, this is not our answer yet. Our answer would be all the fractions that we can create by using these 3 numerators combined with these 3 denominators, okay? So our final actual potential zeros would be positive and negative, and then we're going to put 1 over 1, 2 over 1, and 4 over 1. And then 1 over 2, 2 over 2, 4 over 2, and then 1 over 4, 2 over 4, and 4 over 4. We need to combine and make every pairing that we can with those numbers. So, again, 1 over 1 is just 1. 2 over 1 is just 2. And 4 over 1 is just 4. Then we're going to match all of these with the 2. 1 over 2, that's 1/2. 2 over 2, wait a minute, that's 1. And we already have that, so we don't need to write it again. Same with 4 over 2. 4 over 2 is 2, and we already have that number, so we don't need to write it down twice. Then we have 1 over 4. We don't have that. And then 2 over 4, but that would be 1/2, so we're good there. And then 4 over 4, but that would be 1. So these numbers, these 1, 2, 3, 4, 5, plus the other 5 negative versions of those numbers, these are the only possible numbers that have a chance of working. So I am not going to test the number 3 and see if it works. It won't. I'm not going to test the number 5. I'm also not going to start by testing these. I'm going to start here. I'm going to start with easy, small numbers, and I'm going to see if I can find some answers there. Okay, so for example, this is this same problem. So we're going to come down here and we're going to go through the steps of finding the zeros of this polynomial. So the first thing you want to do is you want to recognize how many total zeros you're looking for. This has a power of 4, so that's how many zeros there's going to be. There's going to be 4 of them, 4 zeros. Then you want to use what's called the rational zeros theorem, which is the fancy name of that thing we just did, to find the possible or potential zeros. So what are the zeros that have a chance of working? So again, we just found those, but it's the factors of 4 divided by the factors of this 4, and then make all the combinations you can. So plus or minus 1, 2, 4, 1/2, and 1/4. And then that's what we're going to pick and choose from. So I'm going to start with like the number 1. I'm going to see if the number 1 works. I'm also going to use synthetic division to test the number 1. So there's a 1. For synthetic division, I just need these coefficients. So I need 4, negative 15, negative 8, positive 15, and 4. Now once you do a few of these, you're going to start to get pretty quick at it. Because remember, you're just adding and then multiplying. Adding, and then multiplying, adding, what's that, negative 19, multiply, add, and multiply, and add. All right, so that worked. That is one of my zeros. Okay, so this is one of my zeros, which also means I know one of my factors. If you look at the bottom, it's going to say, list the zeros, so I should have 4 zeros, but also write the polynomial in factored form. So we want to rewrite our function as a set of parentheses times a set of parentheses times a set of parentheses times one more. Okay? So if positive 1 is one of my zeros, that means x minus 1 is one of my factors. All right, so now what? So remember what just happened. We just took this polynomial that is x to the 4th power. We just divided it essentially by this factor, which is x minus 1, which is an x to the 1st power, which means the answer is going to be an x to the 3rd power. Because if you divide an x to the 4th by an x, you're going to get x cubed. So this answer is 4x cubed minus 11x squared minus 19x minus 4. That's what that is. And since we, again, don't have a clever way of, factoring, like factor by grouping, for x cubed, we're just going to have to repeat this process. Now, don't go back to the original. That's gone. We have found one factor, we factored out, now we have an x cubed, and now we want to test this. So that's what this step 4 is saying. We've reduced this, so now let's test it again and try something else. All right, so again, it's got to come from this list. So you could go across. We tried positive 1. Positive 1 could actually work again, but I'd probably try something different, like positive 2, positive 4. You could also go negative. Some people like to go positive 1, negative 1, positive 2, negative 2. I'm going to try negative 1. And again, I'm doing it with this new number, 4, negative 11, negative 19, and negative 4, which is smaller than my previous one, so the synthetic division should go more quickly. So bring down the 4. That's a negative 4, negative 15. That's not going to be a positive 15, negative 4, positive 4, 0. Hey, it worked. So what do I know? I know that negative 1 is another one of my zeros. That means that x plus 1 is another one of my factors. And I also know that that x cubed just got divided by an x, so this is now an x squared. 4x squared minus 15x minus 4. In quadratics, we do have ways of factoring. So you could either do factor by grouping, take 4 times negative 4, get negative 16. Factors of negative 16 that add up to negative 15. That's how you would split the negative 15, and then you would do your factor by grouping. You know me, I like to just go straight at it. I'm going to say 4x and x. Again, that factor by grouping, factors of negative 16 that add up to negative 15 is going to be negative 16 and positive 1. That's what I want my outer and my inner to be. So if I get a negative 16, so here's negative 16, and a positive 1, my outer and my inner are going to add up to negative 15. So those are my other two factors. 4x plus 1 and x minus 4. So what are those zeros? Well, negative 1 divided by 4 and 4. And again, both of those new numbers are still in this list of my potential zeros. It's got to come from that list right there. So there's the negative 1/4 and then also a positive 4. Okay? Now what we're going to do, and on your homework, you're going to see some graphs. So what do I know about this graph? Well, I know the y-intercept would be 4. 1, 2, 3, 4. I know these 4 numbers are x-intercepts, so like positive 1, 2, 3, 4, negative 1, and also negative 1/4. That's going to be hard to draw. Okay, so those are my x and my y-intercept. I also know that the ends of this graph, because this is an x to the 4th, should be going up and up. So my graph is going to start up here. It's going to cross the x-axis. It's going to have to turn around, cross the x-axis, cross the y-axis. It's going to cross the x-axis and cross the x-axis again. So that would be a quick little sketch of what this polynomial probably looks like. Okay? So take a look at your worksheet and let me know if you have any questions.